Well, the idea behind Hyper-V is that it is going to be hardware virtualization. Now, normally, when you're dealing with computer systems, you're going to have a single operating system running on a single machine. And any applications that you run on that operating system are going to have their little separate areas of memory, but they may also have common areas of memory, and they're all using the same operating system, which means all these applications have to sort of trust each other, or you have to, as an administrator, trust the other applications that are in there. Because if you have one bad application that's acting improperly, it can bring down the entire house of cards, including the operating system for the main machine. Also, there's certain applications that don't get along with each other. Maybe you have different versions of a line of business application, and you're only allowed to install a particular version at a time. Also, you may end up where you have to have certain configurations of an operating system for a line of business application to work, or even for a third-party application, or even something from Microsoft. And in order for that to be common, you have to have a certain operating system with certain service packs and all that. But if I want to run multiple applications that may have different combinations that are required, I'm going to have a dedicated machine. So what Hyper-V does is allows you to go through and virtualize the hardware. So we are going to have computer hardware, CPU and memory and network and storage and all that. But instead of it being devoted to just a single machine, we are going to create virtual machines. These virtual machines are just like physical machines, except they're not physical, they're virtual. And these machines are going to operate in an independent model. So if we look at the hardware model, we have a very small area called the hypervisor. So this is a hypervisor, and that's where Hyper-V comes from. It's a hypervisor. And if I'm running virtual machines, they want to talk to the CPU and the disk drives and the network and the RAM. And instead of emulating all this stuff, we will just go through this little hypervisor that just has a little slice of software so that these virtual machines will be able to communicate directly to these particular devices through these hypervisors. Now, of course, you are going to have a host operating system that's running on the physical machine that handles all of this stuff, but each of these applications, each of these virtual machines are going to have their own environment where they will have their own operating system, their own service packs, their own updates, everything. And it's going to act and seem just like it's its own machine. It just happens to be on a shared physical platform. And this hypervisor is going to make it so that we don't have to have the host operating system try and pretend to be a hard drive, or pretend to be separate RAM, or pretend to be anything else. Instead, the calls from the virtual machine will go through the hypervisor and then talk directly to the hardware that we decide to expose. Also, this allows us to get a lot more utilization out of our systems because, you know, if I have a line of business app and I have to buy a fairly beefy machine, but once I have it installed and it's running, it's only running at 20%, and then I have to buy another app, a server for another app, and another server for another app, and another server for another app, I end up with a data center that has tons and tons and tons of servers, and each one of these servers are only running at 10 or 15%. And that's a big waste of money. So I can consolidate a lot of these roles, put them onto a single physical machine. Of course, you know, you want to have high availability. We'll talk about that when we get into Chapter 2, where we talk about clustering. But we consolidate these roles, and so now this $30,000 or $40,000 machine, instead of running at 10 or 15% utilization, we can run it at 70 or 80% utilization, and yet still have that security and that isolation and protection for our applications. And another big advantage is that if necessary, if I have a machine that starts to have a problem, I can have another Hyper-V host. And as this virtual machine is starting to have a problem because maybe we have too many resources being used, or maybe a lot of people are using a SQL server and it's starting to slow stuff down, I can have it automatically move these components over here. Now, there is a little bit of vocabulary that we need to be aware of. And one of the first pieces of vocabulary is the host versus the guest. The host operating system, also known as the host partition, is what runs the physical system. And it could be a full-blown operating system like Windows Server 2016 Data Center, which is designed for Hyper-V as well as a lot of other things. Or it could be a specialty operating system like Windows Server 2016 Hyper-V. or it could even be a standard version, or even Windows 10, where you're allowed to have Hyper-V clients on there. But that is what runs the physical machine and also controls a lot of the interactions of these virtual machines. These virtual machines are known as guest operating systems. They also call them guest partitions. And in order for this to run, the guest operating system is usually going to need to be Hyper-V aware. You can run whatever operating system you want, but if it's not Hyper-V aware, what tends to happen is that we have to emulate the operating system, and then it's going to be a lot slower. So Windows Server 2008 or later, Vista Service Pack 2 or later. We have Linux editions like CentOS, Red Hat Enterprise, Debian, Oracle, SUSE, Ubuntu. There's a bunch of them. FreeBSD is supported. But you do need to check before you go out and spend a whole bunch of money on a server and just find out that it's not going to work for you.